All right, cool. So we started solving linear equations. So now we're going to solve advanced linear equations. So this is probably going to be, or probably I've already looked at it. This is going to be more about when you have to do more steps to solve a linear equation. So we're going to get into this a little bit more. So let's start off here. Again, feel free to watch the intros and everything on your own. I know the beginning does that Ferris wheel thing. So name of the tutorial. So our objective for this, again, I'm not a big fan of how they put it in the state language, but let's kind of break it down. So create equations and inequalities with one variable. So that's just making equations. So remember, equations mean it's an equal sign. Inequality is this idea that you can have it greater than or equal to, just greater than, just less than or equal to. That's what it means by inequality. Not necessarily equal. You kind of can go over or under. Represent constraints of equations or inequalities with a system of equations. So a system of equations just means we're going to have more than one function intersecting and stuff like that. And constraints just is this idea of like, let's say we want less than a line, but greater than another line. So we end up getting like this area in the middle that kind of constrains it. So that's why it wants us focusing on inequalities, because inequalities are going to help us know where we're going to do it. Explain one-step solving. So we already kind of did one-step solving of equations. So we're just going to add that with constraints. Construct a viable argument. So we're basically just going to make equations from here. Solve linear equations and inequalities with one variable, including equations with coefficients represented by letters. So by this, they're talking about this idea of like, we don't know everything. We might have it like this. This is an equation of a line, for example. It could be like this. This is a line also because if we subtract the AX, this is supposed to be a Y. I'm sorry, guys. My writing's terrible. If we subtract the AX and then divide by B, we're going to get something that looks like this. Y equals negative A over B plus C over B. Almost forgot my X here. So it's still a linear equation. It still has this thing, and it still has another, it still has this slope, and it still has this y-intercept. It just looks different. So instead of it being a B, it's C divided by a big B. Instead of it being just an M, it's negative A divided by B. So that's what it means here by solving it with coefficients represented by letters. These are our coefficients. They're represented by letters. So that's what they kind of expect us to learn from this unit. So let's get into it. So here, I hate how this always starts off answered. So here, solving this equation means finding what makes it true. So in order to find out what makes this true, we're going to have to do things to kind of balance it out. What does X have to be in order for this to be true? So if we do this, well, what I want to do is I want to get all my like terms on one side. So I usually like kind of circling them with different colors or underlining them with different colors. If you guys don't have colors, what you can do is just circle some, underline the other ones. It kind of helps out. So what I'm going to do is I'm going to subtract this 4x to get all of them on one side, because always remember we have this equal sign kind of separating it as this weight. So if I take it away from this side, I have to take it away from this side. So that's going to give me this 4x minus 8 equals positive 12. Now I want to get rid of this negative 8. And if I'm adding something to this side, so if I add something down here, I have to add something over here to keep it balanced. So I have to add 8. So this ends up being 4x equals 20. And now I'm going to divide. I don't know how to draw a picture for me dividing, but the same thing kind of goes. So in other words, this has to be 5 in order for it to be true. Does that kind of make sense, guys? Cool. All right. So next thing, moving on. So we're going to be introducing, so Jared. Hi, Jared. Oh, hi, Donna. Donna, what the way I'm doing for attendance now is you can scroll up and I ask the question. Just answer the question. That way I can always go back and take attendance for everybody. So Jared made more than 2 points, 7 more. So he's doing 7 more 2-pointers than 3-pointers. So what's happening here is I'm going to do 3, or I'm going to do 2 as my W. I'm going to call this my W, or to make it easier, I can always call it my Y. So I'm going to call it my Y just to make it easier. He scored 2 more than his 3-pointer. So we're going to call this X. His 3-pointers are X. So in other words, Y equals X plus 7. How many of these did he score? Well, you're going to take the 3-pointers and add 7. Zach scored only 2 points, making 3 more 2 points than Jared did. So Zach is our Z. So how many points did each player score? So if we're looking at this, we're looking at something like Y equals 7 plus X, and Zach is only scoring 3-pointers, or 2-pointers, sorry. He's only scoring 2-point baskets, making 3 more 2 points than Jared did. So Jared is scoring this Zach. So I'm going to say Z equals Zach's, or Jared, sorry. It's going to be 3 more than that. So we're going to put X plus 3. Sorry, I kept getting the names mixed up. So Zach, I'm going to call him Z. So Zach equals X, which is Jared's 2-pointers, plus 3 more. So in order to figure out how much Zach scored, we have to figure out all of this information. So we're going to get into how we can do something like this later on. So this is how we can actually use math to kind of solve this. We can use algebra, is this idea of assigning names to things. It's not just a simple like, oh, what do we do? So here, what they're doing here is they're breaking it up into a nice little chart, which I should have done because you saw how I struggled to kind of write all of that stuff down. They're writing Jared's. How many 3-point baskets? So 3 points. They did a little bit backwards than me. They're saying 3 points. Actually, no, that's what I did. And then in order to do it for Zach, what they're going to do here is he scored 0 3-pointers. So right off the back, we're doing that. And an interesting thing that they did here is instead of going, oh, I'm going to take the 2-pointers that he scored, the Y plus 3, they're like, oh, we're just going to call it 10. They're just adding 3 to this, so they get this 10. So they're making it a lot easier by doing this graph. Instead of having 3 variables like I did, what they're doing is they're like, we're going to have 1 variable. We're going to make this chart to make it organized, and we're just going to add 3 more here to make it a lot more organized. And then what they're going to do here is like, how do we figure out how many he scored? Well, we're going to take this number and multiply it by 2. We're going to take this number, multiply it by 2. Well, Then we're stuck with 3 pointers. Oh, well, 3 pointers, we're going to take this number times 3, and that's how we're going to solve this. So they did it nicely. They kind of broke it up. So you can see the benefit of it because you saw, like, I was like, wait, Jared is who? Zach is who? They kind of like organized it. You don't have to always do this, but because we're dealing with one variable, it does make it a lot easier to solve using this little chart. We'll kind of get into how to do it later. So this is how we would solve for this. And then we would have, once we know what x is, because we're saying that they scored the same number of points. So somehow they scored the same number of points in between themselves. So we can make these equal. Once we make them equal, we know how many 3-pointers they shot. Does that make sense, guys? Cool. And again, those of you who have joined us a little later, make sure to scroll up on the chat. So go on the chat, read the question for today, and then answer the question. That's going to be how I take attendance. All right. So going here, you click the box. So to solve the equation, it's like represented here, we're going to use properties of real numbers. And this. So I think what we're doing here is we can click it, and this is just telling us all the properties that we need to know. So addition and subtraction properties, I think I went over this. These are basically the same idea. One of them we're just subtracting, one of them we're just adding. To me, adding and subtracting are the same thing. It's just whether we're doing it with a positive number, whether we're doing it with a negative number. Same thing with, to me, with multiplying and dividing, because you can technically divide when you multiply by a fraction. So multiplying by a fraction is the same thing as dividing. So that's why a lot of times I just consider multiplication and division the same property. So that's all these are doing. So if you guys need help understanding this, you can always review this. I don't like how they say reflexive property. I kind of like thinking of this property as this idea that every a that we use should be the same. So when we're doing algebra, if we're talking about x, that x should always be the same. If it's not the same, like in this case, x represents, what was it, Jared's 3-pointers. If we're not talking about Jared's 3-pointers, it should be a different letter. Don't use the same letter. You're going to get confused. This one is this idea of equality, just saying that one letter can equal another letter sometimes, so we can substitute. This one's this idea of the transitive property. If things are equal to each other, so if A is equal to B and B is equal to C, we can say that A equals C. Some of these seem a little obvious, but when you get into like higher level math, you kind of have to understand why these things work. Or when you're trying to prove something, it has to follow these criteria. And then symmetry just means if something's equal to something, you can write it backwards and it's okay. So what we're going to do here is first we're going to distribute. Let me move this over here. We're going to distribute this to, because we can't add these two together in the parentheses, we have to move over to distributive property. We're going to distribute it, distribute, and then we can just multiply it out. So that's the first step we would take into solving. Next thing we would do is simplify it. So what they're doing here to simplify is they're taking all our like terms together. So if I highlight this and this, they're combining those ideas. Nothing over here changed because there was nothing to simplify. From here, what they're going to do is they're literally just going to take all of our constants together. What do they call them here? Oh, they're not doing our constants, sorry. They're doing our x values first. I like doing x values first too, but since Edmentum is always like the opposite of me, I thought they were going to do constants. But so what they're doing here is they're subtracting this 2 here. So they're just doing what we've been doing. Whatever you do to one side, you have to do to the other. So that's how we get to the next step. The step after that, they want all of our constants together. Oops, let me use a different color. They want all of these constants together. So that's why we're going to subtract this 14 to make all the constants together. Finally, after doing all that, then we can divide. So that's all we're doing. We're just doing everything step by step by step. So here, if we see these parentheses, might as well distribute, right? We want to do all of the things we can do first. So before we have to start doing the opposites, we have to do all the work we can do. We can't combine these because they're not like terms. So because they're not like terms, we have to use distributive property. Then we have to simplify. After this, we can do combine all of our like terms. So first you want to do all the steps you can do, then you want to simplify. And then after that, we're going to start moving all our numbers to one side. So we're going to choose where we move our ends. And then we're also going to choose where we put all of our constants. That's going to be our next step. Is this making sense so far, guys? Yes, no, maybe? Again, guys, don't be afraid to like ask if you need something explained more. This is a good time to ask when everyone's here because you never know. Sometimes they might have the same concerns that you do. Another way of doing this is after we have this, we can just plug it into the original. So what they're doing here is they're taking this and they're plugging it in here and here, which was the same places we had the end over here. So that's where we can see that they're just plugging it in. And if we get something balanced like this, that means we're good to go. So this is a good way to check your answer. All right. So the next step here, they want us to they're doing free throws. Jared attempted X shots and got 70% of them. So when you guys think 70%, think 70 per 100. The word percent literally means per 100. So it's a fraction. And if another way of thinking about it is you just put a decimal 2 spaces over. To turn a percent to a decimal, just move it 2 spaces over. That's all you have to do. And to prove that all of these are the same, let me grab my Google calculator real quick. Later. 75 divided by 100, 0.75. So if we're talking about 0.75, let me close some of these. If we're talking about 75% of X shots, we're talking about 0.75 times X. Zach attempted 10 more shots than Jared. So in other words, Zach did X plus 10 shots and made 80%. So in other words, we're going to multiply this by 0.8. You can think of it as 0.80 if you want, because if you move it over, it's technically 0.80. But zeros over here don't mean much, mainly because think of it this way. 0.8, this is 8 in the tens place. This is 80 in the hundreds place. You can just cancel out the zeros and you have the same thing. So in case you guys were ever wondering, like if you learned it in middle school and stuff, when you had to learn like this is the ones place, this is the tens place, and then over here it's like this is the tenths place, this is the hundredths place. That's this idea right here. So if I had 0.01, this is 0.1 in the hundredths place. That's where those names come from. I feel like they never explained that in elementary school. They just made you memorize them for no reason. All right. So that's when we're going to have this thing here. And it's saying together they did this many shots. Which equation represents it better? So in other words, they made that many shots. So this represents how many they actually made. 75% out of the shots he took, that's how much he made. And then the other thing is like how much this made. And together. So this word together means we're going to add them together. And that's going to equal 101. Does that make sense, guys? Why we're adding it, why we're setting it equal? Any of it doesn't make any sense, why we're multiplying or anything, let me know. Just say, oh, well, the multiplication doesn't make any sense. The parentheses don't make any sense. Let me know. But from here, that just means that our answer is going to be, we're doing the multiplication. This doesn't even have the 101. So we know this one can't be it. This one, I don't know why we're multiplying it by the shots. We're multiplying Jared's accuracy. So Jared's accuracy with Zach's shots. That's kind of weird to me. So we know this one's wrong. So here we have Jared's, we have everything for Jared correct, but this doesn't make any sense. He didn't only take, you're not going to say he only took X shots and every shot after that he made. That doesn't make any sense. This is how many shots he took, and it's 80% accurate. So that's how come this one's wrong, is it's only multiplying it by the X, but it's not 80% accuracy out of Jared's shots. It's 80% accuracy out of Zach's shots. So this X plus 10 represents Zach's shot. So our answer is this one. So moving on to this next one. So now we have to solve for the shots. So again, we're looking at our equation that we just made up. This becomes 0.75x plus 0.8x plus 80. What a difference that made having this parentheses, right? It would have been plus 10 if we didn't put the parentheses, but because we did, it's 80 shots different. So right off the back, we have to say that we have to take away these 80, or there's several ways to do this. I like taking away all of it right away, but according to Edmentum, they want us to add these up first, and that's fine. So we can grab a calculator if we don't feel comfortable. So 0.75 plus 0.8, we get this 1.55. So we're going to get this 1.55x plus 80 equals 101. I want to put all of my constants, again, numbers that don't have a letter are constants. We're going to move those over to one side. 80, 80. So this should be 1.55x equals 100 is 20, and then we have that extra 1. So now I just have to divide this out. Grab my calculator. 21 divided by 1.55. Getting about 13 shots. Let me see if I got anything wrong here. 101. No. So I'm getting about 14. So I'm a little curious as to how Edmentum's going to answer this. 60 shots. How did they get 60 shots? 70% times that. Distribute that. What did I do wrong here? Oh, it's 0.8. I'm so sorry, guys. I was thinking, so I multiplied 8 times 10. I was supposed to do 0.8 times 10. So sorry about that. I don't know how that happened. Either way, it's still a difference. I know before I was like, well, one of them's 10, one of them's 80. In this case, there is a difference, that 10 versus that 8. So that was my bad. I forgot to distribute this decimal. That changes everything. So that's how they're getting this 93 here. Does that make sense? You guys need me to re-explain it because of the fact that I multiplied it wrong? Okay. Yeah, it makes sense. Okay, cool. So again, sorry about that. That was just it being early for me, and I forgot to do that. And let's get into this. So when we're doing this, they want us to kind of explain what we want to do first. Well, the first thing we want to do is we want to get rid of this negative 2/3. And we're going to do that by doing the distributive property. If you guys see this negative 2/3 times this 12 and you're scared, remember, it's not that bad. All we're doing is we have a choice. We can either multiply first or divide first. So I'm going to show you multiply first. Negative 24 divided by 3. Well, that's just negative 8. Let's pretend I divided first. So I'm going to divide this 12 by this 3. I'm going to end up getting 4. So in other words, I have negative 2 times 4, and that equals negative 8. So that's how we're getting this negative 8 right here. That's all we're doing. It's not that bad. If you guys see these fractions, just think of fractions as it's a choice. Do I want to multiply first or do I want to divide first? So first things first, we're going to distribute. So right here, right off the back, that's the distributive property. Distributive prop. Over here, well, now if we notice, they're kind of combining these like terms, right? So they're adding, I guess in this case it would be more like subtracting, but they're adding like terms, subtracting like terms. Either way, it's the it's the additive or the substitution property, right? So if we look down here, since we're subtracting, we're going to use the, where's the subtraction property? I guess we're using this one of equality. We're going to subtract it out. But I feel like, nope, that has to be it. And now that we have this down, we want to get rid of this. So we're going to add it to both sides. So that one's going to be the additive property. So this one, I guess we can change to subtracting. And then from here, we have this negative third, right? Or we can view this as negative x over 3. Because we can multiply it out. So we can just multiply this by negative 3. Or we can multiply this by negative 3 over 1 if we'd like. That crosses this out, crosses that out. Negatives cancel each other. So fractions just have a lot of options. Just remember that. So what I would do is I would multiply these two first to give us that negative x divided by 3. And then want to get rid of the negative, so I multiply by negative 3. Negatives cancel, 3's cancel, and we're left with just x. So this tells me we're dealing with the multiplication property of equality. And then here, I like it too, so I can't just say like they like it. I like having this on the same side. So From here, what we're going to do is we are going to, oh, I didn't realize there was a combined like terms option for this one. They just switch it. So this is just the symmetric property. One side is equal to the other. And just to get all the answers filled in for you guys, there we go. So distributive, combined like terms, additive property because we're adding to both sides. We're multiplying to both sides. And then it's just symmetric. All right, and then just rate this on how you think you did. If you had trouble like knowing these, feel free to write it down here. Like, oh, I had trouble knowing this. Mine, I would say something like, oh, I didn't see this combined like terms. So that would be something I would write is I thought we were going to have to do the additive property, but it turns out there's a like terms property that I didn't see. And I would also write something like I distributed an 8 instead of distributing a 0.8, which made a huge difference in my calculation. All right, proportion. So proportions are just this idea of fractions. For every 2, I get 3. So if you win 4, so if I have 2 over 3, that's the same thing as saying 4 over x. This is usually, whenever you see a fraction, guys, it's going to be cross multiplication. Always, always, always. And if you guys ever wondered where cross multiplication came from, I'm going to show you right now. This idea comes from, I want to get rid of this 3, so I'm going to multiply by 3. So now I get this 2 equals 3 times 4 on the top divided by x. Well, now I want to get rid of this x. So I'm going to multiply both sides by x. So I get 2x equals 4 times 3. Well, that's the same thing as doing 4 times 3 equals 2 times x. That's where this cross multiplication comes from. Sometimes I've heard people call it the butterfly method. I mean, oops. I don't know. To me, this doesn't really look like a butterfly. I guess it kind of does. But that's where that comes from. You're just multiplying. So what they're doing here, they're doing this 2 to 3 and 4 games losses. So the team won. Oh, always read your problems, guys, because the team has won 4 more games than it's lost. So it's doing this x plus this. Same idea is going to apply. I just thought it was saying that they won 4 games, or they, I guess in this case, lost 4 games. So just make sure you're reading this all the way through. I'm just skimming this really fast, and there's dangers to doing that. So they're doing this fraction. Then from here, like I said before, we're going to do cross multiplication. So they already did that cross multiplication. Distribute it and combine like terms and divide. Everybody good on this? Besides the part where I messed up and I forgot to read the whole part right here. Cool. All right. So first things first, what are we going to do to solve this? So click each step in order. So the first thing I see here is I want to cross multiply. There's nothing I can do to simplify. I want to cross multiply. So I want this 4 times this 2 and minus 7 is going to be equal to this 3 times n plus 9. So 3n plus 9. Sorry, I know it looks terrible because I forgot to color code it. So what's my first step? I want to cross multiply. See a fraction equal to a fraction? That tells me cross multiply. Boom, that's going to be my first step. After this, I want to distribute. So from here, I want to distribute. Boom, boom. So that's going to be 8 and that. So my next step after this is going to be this. From here, oh, this is just literally distributing. From here, I want to put all of my like terms together. So I'm going to subtract that 3n. At this point, I want to add this 28 to both sides. So that's going to be additive property. And then I'm going to divide to sum it all up. All right, here. So I hate how Edmentum, since I'm a teacher, gives me the answer right away. But just to kind of sum this up really fast, we know the answer is -9. But we're going to distribute this. So we get 5 times that, because we're cross multiplying. Cross multiply, we get this equals 2, 3p plus 7. Distribute, we get 5p plus 5. Distribute on this side, we get 6p plus 14. I'm sorry, I know I'm going fast. Let me know if you guys want me to slow down. But a lot of this I'm just doing really fast just because I have it memorized. So you guys remember, I'm just doing this to kind of keep you guys like at a good pace for the class. I don't want you guys like falling behind. So that's how come I try to do this fast. There's no problem with you guys taking long on assignments. That's perfectly fine. This is just kind of like a sum up of how we're doing it, why we're doing the things we're doing. If you guys don't have the methods down, we can always do a tutoring appointment. Or again, I have all this memorized, so I do go through it a little fast. So that's pretty much how we do this. So now we're going to talk about number of solutions. Sometimes we can have more than one solution. So if it is a linear equation, we can have a few options here. So they're going to talk about linear equations. So linear equations, we can have one solution. We have two lines. They cross each other one time. So this is an example of one solution. No solution, we have our line here, and we have another line here, and guess what? They have the same slope. This is the idea of, like, let's say we're talking about how much money someone has in savings, and someone started off with $20 in savings, and then they put in like $10 a week, versus this other person over here who had $0 in savings, but they're also putting $10 a week. There's never going to be a point in time where the savings accounts are the same at the exact same time. But they will reach each other. It's just at a later time because this person started off with more money. So that's why there'll never be a solution. It's like, when are their savings account going to meet? Never, because they're saving the most. If the person with no money in savings wants to catch up, they're going to have to start putting more money. They're going to have to change their slope in order to meet up. So that's an example of no solution. No solution would be parallel lines. Infinitely many solutions, that's this idea of you have a line, and then someone started off a little bit later, but at a later date, and their line overlaps. That's what it means by infinitely many solutions. Oh, when are the bank accounts going to be the same? Always, from now until forever. It's always going to be the same. This can happen where it's like, oh, I put $10 a week in there, and versus someone else who's like, oh, I put $10 a week, and so their slope ends up being exactly the same. That's what it means by infinitely many solutions. It's literally the same thing. When are their bank accounts the same? Always. When are these two bank accounts the same? Never. They're putting the same rate. Someone's spending money, someone's saving money. That's what it means by no solution, one solution, or infinitely many. It's the same line. We'll look into how it can look different. No solution. How does this look from algebra standpoint? No solution from an algebra standpoint means all of our x's go away, And then we get this very weird thing where this doesn't work. This is what it means by these lines are parallel, is our x's go away and we're left with something that doesn't make sense. That's what it means by no solution. One solution means we're going to get this x is something. We're going to get this exact point where x equals something. When it looks like infinitely many, a line over a line, we're going to get something like 6 equals 6. It doesn't have to be 6 equals 6. It could be like 4 equals 4, whatever. It's always true. When is 6 equal to 6? Always. Infinitely many solutions. When is x equal to -1? One time. There's only one time when x equals -1. Out of all the numbers in the world, there's only one time. When does 4 equal -6? Never. There's no solution. There's never a point in time when 4 equals -6. So moving on over here. Edmentum, why you do this? Well, since you guys already saw it, and those of you watching on YouTube can always pause it. There's no point in me solving this. I'll explain why this is no solution, even though you guys have the answers, and you guys can always like watch this on YouTube later to get the answers that much faster. If I distribute this, I get 2y, sorry, I'm used to x, equals that. We're going to add that 3 or 5, so we get 3. Let me know if I'm going too fast, guys. So this, we would end up getting this here. I can take away this 2y from both sides, and I get -3 equals +3. When is that true? Never. This one over here, I don't like these fractions. Like, these fractions are terrible to me. So what I'm going to do is my denominators are 3 and 5. I'm just going to multiply everything by 15 just to get rid of these fractions. I don't like them. I'm just going to multiply everything by 15. So I have 15 divided by 5 times f. I'm multiplying this by 15. That's just going to give me 3f, basically. And then I'm going to get 15 times 2, that's 30 divided by 3. That's just basically going to give me this 10. And then I'm going to get equals to -15 divided by 5. That's just going to give me, f. That's just going to give me this -3f. And then 2 times 15, that's 30 divided by 3. That's just going to give me a +10. So that's how I kind of deal with fractions, guys. If you guys don't like that, you guys can do your addition and subtraction, and I can teach you guys how to deal with it a little differently. Do you guys kind of understand what I mean when I'm doing this, how I got rid of the fractions? Does anybody need me to go over how I came up with multiplying by 15? Understand it? Anybody else? Uh, what do you mean by no? Does that mean you don't need me to go over it, or does that mean you don't understand it? Okay, just making sure. All right, cool. So that's basically how we would solve for these. This right here, infinitely many solutions, at some point down the line for this one, we ended up with something equals something else. So, or same thing here. So I'm just going to go through these really fast. I'm just going to go through the bottom one really fast because it looks easier than having to distribute. So right off the back, I know I can cancel out these negatives, or these 2.8. And then I'm going to combine these two together. So if I combine those together, 1.4 minus 3.1, I get this negative negative 1.7v equals negative 1.7 v. I can honestly stop right here. When does negative 1.7v equal negative 1.7v? Always. There's infinitely many solutions. These two are the same line. They just look a little different. That's all it is. Summary. So the summary here is we're going to use distributive property. When we're doing proportions, we're doing cross multiplication. Fraction equal to fraction, cross multiplication. Solutions. If A equals B, that means that there's no solution. This right here, no solution, never works. X equals A. I'm surprised we were supposed to go over inequalities, but I guess they're just focusing more on how to solve more complicated solutions. All right, guys. Well, that's pretty much it. As always, when you guys are working on this, do your practice problems. If you're not understanding the practice problems, read those solutions. Remember, this practice doesn't affect your grade. So you get a low score on here, but only the mastery test affects your grade. So this is a good way to practice for your mastery test. Other than that, anybody who hasn't answered this morning's question, go ahead and do that before you signed off. The morning question was, what have you learned this week? And again, it doesn't have to be for this class. So just write down somewhere in the box below, what have you learned this week? If you already answered that, you guys are free to go. So, you too. Let me stop the recording.